Right. All right. Good evening, everyone. Thank you all for coming. My name is Todd Brous. I'm your host for the evening. I'm here with Susan Schultz and Ashley Wilson, and we would like to welcome everyone to HBAP Startups. So let's get started. For those of you who are new to the Startups group, we have a few announcements at the beginning of each meeting. We'll do some short networking breakout rooms, and then we'll come back together for our main event. And first off is our mission. We're here to help foster and fortify an innovation and entrepreneur community coming out of the Harvard Business Analytics program. And our goal is to provide our members with the tools, knowledge, leadership, and confidence necessary to create and grow their businesses from the ground up. Susan. Oh, you're muted.
Got it.
There we go.
So many ways that you can get in touch with us and stay in touch with us. We have our website, we have our YouTube channel where every presenter that has given us permission to post their presentation has it up there. So lots of super cool things there. We have a newsletter. All this stuff is going to go into the chat, and you don't have to be an HBAPer to do this. And I can see there's some people here tonight that are not HBAPers, so welcome. And then for those of you that are in HBAP, there's a Slack channel. You can stay in touch with us there. And then bring a guest. This is a really cool community here. So bring a guest of people that are interested in meeting interesting people, talking about interesting ideas and all of that kind of stuff. And then just a reminder, as long as we have permission, we are recording this and posting it publicly on YouTube. And so today we have Anna, and this is going to be so cool. And then we are closing out this year with two additional really interesting speakers. One is Clisonda Armstrong Grandison, who is a 34-year design professional. She recently decided to leave United Airlines, where she was head of the whole UX leadership for all of United Airlines worldwide, to go to Alaska Airlines to be their director of design. So she has a lot of experience in the design community, but she also has several startups herself. And she's going to be talking to us not just about, what makes good UX, but also her startup journey, as well as like, how do you engage your customers in the right way? And what are the kinds of things to think about? And then on the 18th, we have Mag Atem, who I actually met through the Cameroonian connection that many of us have here. And she is the owner and managing director of Alim Technologies and also a project manager for Atrium Health. And what she does with Alim Technologies, her startup that she founded, is she really is driving the use of data, information technology, and AI, especially focused in government agencies as well as private sectors. And what's really cool about her is she has this massive passion for how do you actually use AI to improve productivity and really helping all kinds of people connect the dots between what they're doing and how awesome AI can be to help make everybody more productive and better. And so she's going to talk a lot about her journey with us and then her passion for AI and some of the things that she's been trying out as well in her career and in her startup with AI. And then we have our holiday break and New Year's Day, and then we'll start the new year. And we've got many interesting speakers coming up for the new year as well. So just a reminder that this is a community where we really want to foster an inclusive environment of collaboration and trust. And so always a reminder that all rights are reserved by the presenter, and we follow our honor codes, and we follow the feedback approach from Francis Fry, which is pretty much just give positive feedback that works the best for everybody. But if you do need to give something that's a little tartar, make sure that the ratio is high on positive and lower on the tart side. And then just a reminder, because we're honoring our presenters' confidentiality and rights, no personal recording of our sessions. And then as always, if you've got something you want to talk about, an idea you want to present, a speaker that you want to bring, just let Todd, me, or Ashley know, and we're happy to talk to you about it.
Awesome. Thank you, Susan. All right, I'm struggling with the breakout rooms. I think this is going to work. I'll give you 5 minutes, 6 minutes, and I'll see you all in a little while. Randomly selected. All right, welcome back. Hope everyone had fun in their breakout rooms. Just as a little reminder, when you exit Zoom this evening, there'll be a little pop-up window with a survey in your favorite web browser. So please do fill out that survey. We are data analytics people. We love getting access to information and data. So please fill that out. After we're done, we will end the recording, and we will also post the recording publicly on YouTube. So please do stick around for some overtime afterwards. Let me hold on a second. Let me start that. Okay. First off, I want to thank Kelly Kimball for bringing us tonight's guest, and it is my honor to introduce tonight's speaker, Anna Cheniuntai. After earning her bachelor's degree in space physics in 2014, Anna made a leap into entrepreneurship and joined the construction and industrial machinery industry. At 22, Anna had successfully managed a massive $6 million project to construct and deploy the ground navigation system at the Sochi Olympic Games in 2014, because people getting lost at the Olympics is not fun. This experience became a turning point for Anna and her co-founder, Nick, recognizing the construction industry was in desperate need of automation. Anna co-founded Apis Cor, a construction technology company that robotically 3D prints full-scale houses. We're talking Insta-house, just add water. And they've got improvements on multiple metrics from precision, speed, workflow, safety, cost, across the board. And today, Apis Cor works with D.R. Horton, with the largest national home builder in the United States. They hold a Guinness World Record for the largest 3D printed building on planet Earth. Yeah, planet Earth. They are also finalists, which is a great segue. They're finalists of NASA's 3D printed habitat challenge, and they're backed by VC's Alchemist Accelerator and @One Ventures. Anna is a TEDx speaker and an Unreasonable Group fellow, which is Unreasonable Group. Daniel Epstein came here and spoke in March of 2023. Unreasonable Group is a community that collaborates with entrepreneurs, institutions, and investors to profitably solve pressing global problems. And in her free time, Anna leads the STEM Access Foundation, a nonprofit organization she founded to provide laptops and access to education for post-war and refugee communities. And now, without further ado, as is our custom here at HBAP Startups, if we could all please briefly unmute ourselves, and let's give a warm round of applause to Anna Cheniuntai. Anna.
Woo!
I like it when people cheer. Gives you an audience feel. Anna, thank you for joining us. And Kelly, thank you.
Yeah, thank you so much for having me today. And thank you so much, Kelly, for making that happen for me. Really excited to, spend some time with you today. So I can just continue the story, right?
It's all yours. The floor is yours.
Oh, okay, got it.
Thank you.
Awesome. Yeah, so my name is Anna Cheniuntai. Thank you, Todd, for pronouncing my last name perfectly from the first try. I understand when people not doing this well from the first time, so it's impressive. So I co-founded Apis Cor, the company that 3D print full-scale houses using robots and concrete-like materials. We are currently in Melbourne, Florida. This is where our company is located. I live in San Francisco, finally made it there, really love Silicon Valley and that area. Was trying to get there from first time we came here in this United States, and finally we're there. And I think that I probably I would love to start with the overall story, how I actually ended up here from Siberia. As already was mentioned, I actually was born very far away from the United States. I was born in a pretty small town, actually it was city, in Siberia. It's part of Russia, and it's closer to the border with China. And it's like a 6 hours flight to the closest city in Europe. I spent there almost 25 years in my hometown. I was doing a lot of crazy things. I always want to be entrepreneur. Me and my sister, we started selling some stuff, things from our home when we were like 10 years old. And then my dad saw it, what we are doing, and we got in a little bit of troubles. But yeah, I was showing my intention to become entrepreneur pretty early. And at the same time, I wanted to do something really big. All the time, something inside of me, yeah, I'm gonna be part of something big. I didn't know what exactly it's gonna be. I never really thought that, oh, maybe someday I will, start doing the robots to 3D print houses. It never was like that. I just really knew that whatever I'm gonna be doing, it's gonna be really impactful, and I really want to do something good for this world. I think I was really impressed in a bad way what actually was happening with our ocean, with our environment, everything across the globe. It was pretty early in my life, and that was kind of like an internal crisis. How are we going to keep living on this earth? And I think this is when my intention to do something really significant and impactful was really reinforced when I was like 17, 18, I think. And thinking about that and realizing all of the problems in the world, I was like, okay, I didn't know what I actually going to study at the university, but I do know that I'm going to be doing something impactful as an entrepreneur, and I'm going to be a part of the big story. And I was like, okay, I'm going to spend the next 5 years studying something really interesting. And I decided to study space physics. And actually, it also was a little bit influenced by my family, because my parents and my grandparents, they all coming from physics and mathematics and geology. They PhDs and bachelors in the physics, math, and geology. So I was like, yeah, it sounds fun. I should probably keep doing the same. And I really wanted to learn how the real world works. And at the same time, my mom, she's actually an entrepreneur as well, and my grandmother as well. And I knew that they were doing science before, and now they're successful entrepreneurs. And their friends, very also like a strong female characters, they also one of the successful people in our city, and they were studied in the medical school. I was like, I don't see a really correlation between your study and what you do in the life. So this is why, yes, space physics is really fun. And this is how I ended up there. And on the last year on my study at university, I met Nick, who also now my husband and co-founder. And Nick, back then, he was already doing a lot of entrepreneurial ventures. He was in construction. He actually was doing construction as an entrepreneur. He was running his little company, and he's also was incredibly talented in robotics and industrial machinery. And when I met him, I was like, oh my God, you are so smart. I really just want to stick with you and do whatever you do. How can I help you? And this is how it started. And I almost dropped out of university because of that. But my mom was like, I didn't know anything about that. You're going to get the diploma. So I was like, okay. So at the same time doing this entrepreneurial real business, I was able to finish my study at university. And soon after, me and Nick, we got a very big construction project at Olympic Games in Sochi 2014 Winter Games. And it was just because we were pretty good at the how to use internet, and that was the era when the government was switching to the electronic system, and all of the contracts and all of the bidding process could be done online. And this is what we did, and Nick already had this experience before with this government contracts. This is how we got this, and we were like at 22, 23 years old. And when we showed up at the Olympic Comet, they were like, oh my God, we're all going to be fired because these kids are going to be managing like all of the millions of people coming to the Olympic Games. But we successfully delivered that. Everybody was happy. And this is how we made our first big money together. And because the contract, actually, what we were doing at Sochi, to give you a little bit more details, we had to design, fabricate, and deploy 5,000 navigation signages. So all of the millions of visitors who comes into the Olympic Games infrastructure, they could see where the train station, where is the Olympic Stadium, where the toilet, where is the ATM. And that was a huge, massive project. So this is why all of the stakeholders, when they saw us, they're like, oh my God, it's going to be disaster. But yeah, we proved them wrong. And this is how we also saw how outdated construction industry was. It was so many delays just because we couldn't have the skilled labor available on time, or the general contractor who was supposed to finish Olympic Stadium or like Olympic Village on time, so we could deploy our navigation signages. They just like, oh, we actually going to complete it in a month. We were like, we're supposed to already complete it in 2 weeks. So we were constantly needed to manage this crazy schedule, and we saw the problem. It's like construction industry is so heavily reliant on skilled labor, which unfortunately pretty hard to find and also expensive, and it's getting worse and worse. And after successfully delivering this project, we were like, okay, what's next? We're really gonna do something big and massive. And Nick basically, and we together combined our experience in construction, in previous ventures in industrial machinery and robots. And then this is how Apis Cor started. And Nick, he's like a really talented engineer and also entrepreneur. He actually came up with the design of the machine that we're using right now. And it's still fully proprietary. This technology, this type of equipment that we designed never existed before. It's true novelty, and it's so exciting to see that it's actually IP rates better and better, and we put in so much knowledge and passion to make this technology better. And so then soon after, once we published the video how it works, it was like a viral effect. Everybody want to see how it works, and they were so fascinated that just a small robot can 3D print a house directly on site. And this is how we get connected with the Dubai municipality. They already were very experienced in the construction 3D printing, but they were not impressed with the previous technologies that they were using. So once they saw what we can, they're like, yeah, we want to 3D print huge, massive building with you. Can you come and do this? Like, of course, challenge accepted. And it was like our early prototype of the printer back then. And basically, it was like our first real project that we were doing. And we successfully delivered that. And it's still Guinness World Record as the largest building 3D printed on Earth. It's a 31 feet tall administrative building, 6,400 square feet of living area, and beautiful administrative building. And we just used single machine to print that because our equipment is quite compact and very easy to operate on site. And at the same time, we were participating in NASA competition. NASA competition was about how this concrete additive robotics technologies can be someday deployed on Moon and Mars to 3D print habitats for first people to arrive there. And obviously, before people can arrive there, robots will be coming there first to 3D print habitats, and then people can come. So the main idea of that competition was, and main requirements, is that to 3D print structures in a fully autonomous way, meaning that it has to be hands-free and nobody really can come and participate in the process. So you're supposed just to push the button, and then 5 hours or 10 hours of printing should be happening without any help. Because when you're on Mars, it's 20 minutes of delay of communication between Earth and Mars. So if something goes wrong on Mars, you will find out only like in 20 minutes. And if you want to send some signal or instructions to the robot to fix it, it will happen 20 minutes later. So even remote intervention also significantly affected the scores that you would get. But we delivered everything on with the best score. It was fully autonomous. We won all of the levels that we participated in. And that was a huge learning curve, huge experience, and very inspiring as well. And then we took some time to keep developing the technology. We later 3D printed the building for the aerospace company in Texas, the leading aerospace company in the world. I'm not supposed to name them, but I guess you get the idea. And then we kept growing in Florida, because Florida is the biggest market for our technology. A lot of single family concrete houses are built here, and all of the problems with the weather, hurricanes, and all of these disasters, it's all the time affecting the availability of houses for people. So you really need to rebuild new houses pretty quickly. And we 3D printed another residential house here. And then we met D.R. Horton, the largest home builder in the United States. They were already familiar with the industry. They invested in our competitor 5 years ago, but they were not really, they didn't really find it suitable for them to be more active with them. And then they discovered us, and since then they've been huge supporters for us. We really enjoy working with them. And so they invested in us, and next year we're going to start printing first real houses with them that they're going to sell. And with the entire idea that we're going to grow and take a pretty significant part of the construction demand and market, at least here in Florida, and then all of the southern states later on. Our idea is just to build as many printers as possible sooner and deploy them with the home builders, so they can use this technology and build faster, more cost effectively, with less impact on the environment. And we just want to provide the best technology and best tool for the home builders. And so then, so yeah, this is how basically this journey in like 5 years, like six years journey, kind of like in a 10 minutes description. And there were a lot of challenges, of course, along the way. Even like fundraising. For example, when we moved here in the United States, I didn't speak English. Honestly, it was enough just to survive and get some groceries and maybe get some directions on the street. And in fact, when I was at school, I was so bad in English. I was hoping that I will never need to study English ever again. And this is why I was so excited about studying space physics, because I was like, awesome, it's going to be only physics and math. And then I was like a first or like a second day at university, and I saw English in the schedule. I was like, wait a second, it's not supposed to be here. And but the teacher turned out very strict, but very, very good. And this is how I started actually liking English first time in my life. But again, like I did not have any plans to ever speak English. I was like, school is done, I never gonna see it again, never need to use it. So yeah, that was kind of like a surprise for me that I actually will need to speak English. And we also didn't have any network here. We didn't know anybody here. It was just me and Nick. We're like, yeah, we need to go to the United States. It's the only place when, all of the possibilities available, all of the opportunities. And we had such a great technology that we did know that the United States is the best place to actually, make it happen on a big scale and change the world realistically. So yeah, we just packed and came here. And then we got accepted to the Alchemist Accelerator. It's one of the top tier accelerators in Silicon Valley. And once we got accepted, the program was supposed to be in person, but then COVID started and it was all virtual. And they were like, okay, now you need to raise money. If you need to raise money, we needed to raise money. So they're like, yeah, go and ask your network, like angel investors, friends and family who would invest in your startup. And I was like, I don't have anybody here. And but Alchemist Accelerator, they were doing a great job to connect us with the potential investors in the community. And I was just pitching to investors over Zoom during COVID about this, that time it was kind of like a crazy idea to 3D print houses robotically. And I was like, yeah, how am I going to do this? But I just kept doing this. And I raised almost $400,000 that year. Again, like I didn't have any network, and my English was a little bit worse than now. And I was like, yeah, that's interesting. And this is how we also got At1 Ventures that year to invest in us. Amazing team, great supporters, and they invest in the deep tech companies who really provides the positive impact to the planet Earth. And the accelerator is the Alchemist Accelerator. This is how the journey significantly accelerated when we met at One Ventures, and then we also kept raising money from the venture investors and angel investors, and then we also started raising money from the crowd. We raised almost $4 million from the crowd. As of today, it's almost 3,000 investors in our company. Check size is like from $250 to like $150,000. And it's really exciting to have so many supporters believing in what we do. And they're just really excited to be part of the journey, how we revolutionize the construction process and construction industry. So, and recently, the biggest, I think, main turning point that happened in my life is that I was accepted as an Unreasonable Fellow. And that was really a life-changing experience for me. This is how I met Kelly and Divya. Really, really happy to see you here. And then I just realized that I actually not crazy. There are more people like that who doing really hard, impactful things. And nothing actually wrong with me or Nick. This is like in a nutshell what I'm doing, my story, and I can tell a bit more about the technology or like how to build on Moon and Mars, or I don't know, what would you like me to proceed from here?
Keep going, Anna. This is fantastic. I definitely think folks would love to hear a little bit about the technology, how you guys developed it, the roadmap, some of the mistakes and lessons learned along the way. I always love asking founders, what did you do wrong?
Yeah, so many things.
Can we see some of the construction? Oh yeah, Kelly just put that in the Zoom chat. He wants to see the
let me share this with you.
Yeah, photos, or it didn't exist, or it didn't happen, right? Is that?
No, we do have it for some reason.
What's the niche market you're just at? Actually, that's a great question. So can you build me a house?
Yes.
Oh,
no, but
okay.
not now.
Oh, not now. Okay, later.
I think I have some problems to share my screen.
Let me make sure that the host tools are not. Oh, you should be able to.
Yeah, I think it's just my internal. If you can give me just 1 minute,
I will take your time. I could edit this out later. It's like.
Is there anything more niche than building a house on Mars?
Right.
Actually, maybe I can just send you a link.
Yeah. Send it to me and I can share it.
Yeah, I just posted in the chat. I think it's just my settings of the laptop. Oops, sorry. Yeah, it's in the chat if you thought can share.
Yep, we got it. Oh, it's a video.
Yep.
Okay, hold on. Let me share this. Share sound. Apis Cor. Can you guys see this?
Yep, I see it. So basically, this is the robotics solution that we have. The printer, and you can see that it's pretty smaller compared to the house footprint, and it's really modular, meaning that you can 3D print buildings of any square footage. You just need to move the printer around the construction site. And this is how we 3D printed the building in Dubai. And also the printer is very compact, so it can fit just a standard trailer, and one person can deliver it on site and one person can operate it. So here you see the actual construction site and how operator uses the laptop to move the printer around. Once the printer is set up on the construction site, on the concrete slab, then the material arrives on site, and printer, we call it Frank. We actually name all of the robots we have. Printer named Frank. We also have mixer, it's Gary. Gary mix the concrete with water and send it to Frank. And here you see that Frank and Gary finishing the house. And now, once the walls are printed, Frank is so compact that it can just leave the house like a printed structure through the door. And then you reinforce the house, you install the insulation, you install the roof, and that's done traditionally by the crew coming on site. And this is how the final product looks like. So this is the real house we recently completed. It's in Melbourne, Florida. If you're ever in this area, just feel free to stop by and check this out. And you also can see that we can 3D print straight walls, but it's also possible to 3D print any shapes and curves and even like a very parametric structures. So it's really given a lot of opportunities for the new design opportunities without creating more costs. And the technology, what is the value proposition for the home builders? First, it's way faster, typically to build the wall structures. And again, we are really tackling right now the construction of the walls itself. And right now you need about like 10 to 12 people on site to build it using the concrete blocks. It's like a big gray bricks. And it can take like 5 weeks to do that, because sometimes you may have all of the 10 people available on site. Tomorrow they are not available. You need to find another subcontractors come in and actually charge you twice more. So it's like a very fragmented process, and you really don't have control pretty much on it if you are the construction company. With Frank, you just print 24 hours a day. Frank never cancels the job, always available on site, and work with the predictable and consistent quality. And we're here not to replace anyone's jobs. In the construction industry, it's such a big gap between how many houses, it's like millions of houses needed to be built yesterday, but we have like a very little amount of labor actually building these houses. And we can see that with the labor shortage and availability of workers, it's getting very hard to get the labor on time, and it's getting very and more expensive. And we can see that like a younger generation, they're not really interested in, mixing the concrete on site under the sun. They would rather be operating the printers, right? So we see that it's going to be very fundamental shift in the industry, and we have to be prepared for that. Otherwise, we just will not be able to have houses and nobody going to be building them. And of course, the costs also associated with that. We can 3D print walls twice more affordable. So it's like a 50% cost savings at scale. And the houses also, but it's also only for the walls, just to be clear, because you're still doing the roofs and windows traditionally. Overall, you can achieve up to 30% cost savings, but it really depends on where you build, what your design. So construction is like a little bit tricky industry. You're never able to claim or say really, like a consistent or like a solid numbers. It's all the time changing. And also the home resilience, it's really important. Here in Florida, for example, your insurance can already get canceled because all the hurricanes and flooding, and it's so hard to get the house insured. And it used to be like $3,000 to insure the single family house in Florida. Now it's like a 13. And people are like, yeah, how are we going to afford it? Not even like a mortgage, but like just the insurance. But with the houses that we built, they are way more stronger. that means that insurance can be way more affordable in the future. And they also can be way more energy efficient, meaning that you will spend less money on your utility bills. This is how you actually can afford more on the payments for the mortgage, right? So we're really talking here not just on the final cost savings for the home builders, but also what is the final cost for to own a house, home ownership price and costs. And with the materials as well, we use a standard concrete right now. It's special blend of a traditional concrete. But in the future, we know how to transition to cement-free materials. And imagine like millions of homes built with the concrete without cement, how big the impact would be on our environment, because concrete is one of the most polluting materials, and cement industry is one of the polluting industries in our world. And yeah, so we given more opportunities to people to actually transition from really hard physical work to become printer operators, helping to save money on the construction and get housing more accessible and affordable, because more and soon and more houses and quicker we build, the bigger supply would be. And this is why we believe that the prices for housing prices can naturally go down. We just need to increase supply. Yeah.
Fantastic. If you folks, if you have any questions, please raise your hands. Mafe, you're up first.
Well, this is exciting. There's a couple question I have. One, of course, you had said that the material at this moment will be changing in the future, and cementless uh, material is really important. So my question, since you have the mixture of this material, is it proprietary to you? And also, what's the R factor? And is it also using the local material in the area to actually be bind to this component?
Yep. Oh yeah, great question. Thank you. So the material that we use, we have our formula. Yes, it's proprietary, but we also work with the other material suppliers who can batch or like produce the material locally. So for example, if we build a house in Orlando or Miami, we can find the supplier locally, or we can produce our material locally with the partners. Because again, like the material that we use, it's already standard type of material in the construction. The secret is like what accelerators and additives you use and what the ratio between them. It's like the Coke, you know. So it's not something that like we need to transport from another planet. And we expanded right now our network of the partners and suppliers. And thanks to Unreasonable Group, we met a lot of strategic partners to like really scale, not just in the United States, but in other countries as well. But yeah, answering your question, we try and we know that supply of the material is critical to scale and have our customers happy and also drive costs down. So answering your question, we able to produce the material locally without crazy transportation, and any dry mortar batch plant can produce our material. It's very well established industry.
And what is the current R factor of your material?
Yep. So the material itself, it basically it's a concrete. So how we talk about the R value is we compare our 3D printed walls to the concrete block walls, like a gray big blocks. CMU blocks, like this masonry block walls, they don't have really significant R value, but you can increase R value once you apply the insulation and also finishing materials. And this is how we can achieve the R value as high as R40. It can be achieved by the insulating material, and also the how wide the wall itself. Because with the 3D printing, we're so flexible what we can print. If you're using just the concrete blocks, you really are stuck with the sizes of that blocks. But for us, we can 3D print 8-inch wall, we can print 10-inch wall, 12, 15, and with the bigger width of the material, the higher R value can be.
Thank you so much, Anna.
Brilliant. Thanks, Mafe. There's a couple of questions in the Zoom chat, but let's go to Kelly then, and we'll go to the Zoom chat, and then we'll go to Steve.
Yeah, Anna kind of brushed over the whole Mars and Moon thing.
Yeah.
The materials on Mars and the material on the Moon are different.
Yep.
The ability to get one of those things up there is difficult. What are the complexities of that, and how did you choose? How is that your North Star? I mean, that's pretty ambitious.
Yeah, and great question, because it's definitely a completely different environment, and it's the temperature changes. It's like crazy throughout the day. It's like 0 to minus 284 Fahrenheit of Celsius. I don't remember, but it's like significant changes. And at the same time, the weather there is very harsh. It's like storms that can destroy everything within like an hour. And another challenge is that we can't really bring a lot of materials from Earth because it's so expensive, and it's just hard to bring we can't really bring sand or concrete from Earth to Mars. It's just going to be so expensive. And so this is how we need to figure out, okay, how we going to source the materials locally. That's really the material science behind that, or like how we can source as much materials local as possible, like a Martian soil, for example, and then we bring some additives in a really small amount so we can activate the soil and print it. That's very challenging, and we have our idea how to do this, but NASA, they were experimenting with the sintering. It's basically when you kind of like melt the sand, or you melt the Martian regolith, and it's you form the structures. There are some challenges behind that, because it's a lot of evaporation when you melt the Martian soil, and it's like how to create this mechanism to do that. So NASA is still working on that. So even NASA doesn't know how to do it yet. They have a lot of concepts. But yeah, this is the challenge. And also for the equipment itself, even the equipment that we have right now, Frank and Gary, it's not really, applicable for Moon and Mars. The idea and concept of small, compact, and mobile robots is applicable, but the entire hardware and the design should be completely different. Because it's a lot of radiation there, the harsh environment conditions, it's going to be different. So we're not there yet, but we do know that printing on other planets or applying the autonomous construction robotics technologies, it's going to be our natural continuation. Because what we're doing right now on Earth, it's already so cutting edge, it's never existed before. And we also know that making the technology autonomous is very important, even for the application here on Earth, because we want to less people, to use this, or like we want our equipment to be as easy as possible to use, and ideally even with the teleoperation, so we can just deploy the robots, let's say in the post weather crisis conditions, and when people really can't really go there, but we can deploy the robots and we can operate them remotely. That will open a lot of opportunities, and it's basically the same thing that we need for Moon and Mars. So we're really excited about that, and we see that it's going to be pretty in the foreseeable future for us. And whatever we do right now on Earth, it's going to be very applicable, or like a natural continuation of that going to be on Moon and Mars.
I love how you're like thinking off of the planet. What we do on Earth is different from what we're going to do on another planet. Yeah, that's like Elon Musk level thought process. Steve, and then we'll go to Vic. Actually, I forgot. There was a couple of questions in the Zoom chat. I wanted to hit those. Brian asked, "What are your biggest challenges scaling this to build single-family homes?"
And just to maybe address a little bit here, our market is not just the single family houses, because the robots are compact and mobile. We can 3D print for example, storages. We can 3D print data centers. We can print infrastructure projects like seawalls or noise barrier walls. So we actually have a lot of, especially our technology has a lot of opportunities for the in terms of applications and markets. But of course, our current focus is the single family housing because it's like a so massive market, and it's really like something that needs to be fixed as soon as possible. And in terms of scaling, for us, it's right now producing more franks, more printers. It's basically like a manufacturing, right? And we all know that to manufacture like a 1, 2, 3, 10 printers or like a, units, it's one thing, but how you actually get the production rate to produce like thousands of them. So manufacturing is quite something that we know is a challenge. We will need to figure this out. But in terms of the building codes, we already figured how to get our houses fully permitted and approved and basically comply with the building codes. Because again, structurally, our walls are comparable to the concrete block walls. It's reinforced the same way, roof is attached the same way, and building officials, when they see our drawings, they're like, oh, you basically concrete block wall. Everything is pretty easy peasy. So yeah, we already achieved quite a lot. Overcame a lot of challenges so far, and now just how we can just keep building organization and have and deploy many printers out there as soon as possible.
Awesome, beautiful. Let's go to Steve, and then we'll go to Victor.
Cool, thanks, Todd. Hey, it's super exciting. I have a question about technology and IP protection, because it seems that one of your big advantages is Frank, is your robot design, and I guess the software that runs it. And if you then go outside and have companies manufacturing this stuff, how do you protect your IP and your design? And do you patent it? And how do you stop suppliers maybe making those things for somebody else? How do you deal with that?
Well, we do have patents, but I think we all can agree that the best protection is like how fast you can move and grow, and basically take in a more part of the market share. And in our case scenario, this is what we believe in, and like we need to keep developing the technology faster than anybody would like to try to copy whatever we have today. Whenever they're trying to copy today, we are going to be like way ahead of time, like 1-2 years later. And also how much it costs for you to produce the printer, because copy is something, it's one thing, but how you can actually copy it in the way that you can still manufacture this at the same low costs, right? It's like a manufacturability. It's a lot of, like a complex moving pieces here, but yeah, we just want to grow fast and become the best technology provider for the home builders, so they will never look at other competitors, because our service is better, our maintenance is better, and we just technologically provide better solutions, even beside the equipment or materials.
Cool. Okay, thank you.
Awesome, thanks, Steve. Let's go to Victor. Where did you go?
Yes.
Oh, there you are. Okay.
Yep. Sorry, I triggered the lowering of the hand too early. Anna, thanks so much for presenting to us tonight. It's really intriguing technology. And I love what you've done to consider things like getting your robot out of a doorway once you've printed it inside. And, it seems like you're really, really thinking well about all of it. I have really 3 areas of question, if you would indulge me. The first one, obviously you have complete control, and I dare say computer control over what you print and the shapes of the structure inside the wall and that. Have you explored, or are your current designs already hurricane tolerant, Cat 5 and potential Cat 6 tolerant, so that after those disaster events, that part of the building could still stand?
Yeah, great question. So our current material and wall structures, they already can be rated as high as for the hurricane category 4 and higher, because concrete block houses can be rated as high as for the category 5 hurricane. We just going to apply the same reinforcement techniques, and this is how our walls can be the same strong as the traditionally built walls. And also our material is already way stronger than the concrete blocks material. Our compressive strength on a 7th day, it's already 3,000 psi, one of the materials that we have. Concrete block is 3,000 psi on 28th day. So it's already stronger. And we also can make even stronger material, but the more stronger the material is, the more expensive it is. So you also need to have the balance, to find the balance. Do you want to really like a bunker, or you want to have like a still relatively strong house, but it's also affordable to build? But yeah, the answer is that we can actually increase significantly resilience of the houses and how they can be resistant to the hurricanes and flooding as well.
Yes, that's excellent. I noticed in the chat, I mentioned Cat 6. I've heard talk of some of these superstorms exceeding Cat 5, and that maybe more categories are coming as, let's say, as the world evolves with whatever is changing on us. The second area, you mentioned the cost. And I just want to put out there that here in New Jersey, there's a decades-old problem of low-income housing. Builders are forced to build a certain percent low-income housing, but it's not profitable for them. So their market houses inevitably become more expensive, or they do it altruistically for whatever financial reasons, or they just argue, the municipalities argue that they don't have the supporting infrastructure and resources for large numbers of low-income housing. But it struck me that your construction technology, at least for that part of the build, could lower costs enough that a traditional builder could do what they do traditionally if they choose for market houses, but also use your technology for building those units that are below market and need to be well below their typical cost.
Yeah, and also a great topic that it brought, because currently if somebody built low income housing or affordable housing, it's immediate as like a thought that it's like it's terrible, really poorly built houses, and nobody want to live in the areas when there's low income houses are built. So with the technology that we have, we can 3D print very decent, good looking and strong houses. And we even can incorporate some of the design techniques, which again, like it will not create more cost to build. And now we have low income housing, but it looks so beautifully. Then other people like living in this, luxury houses, they're like, oh, it's actually pretty good to be nearby. So we believe that we can blur this line between like, oh, really terribly built, cheap houses, and it actually will help to work on the social component of that, because we don't want just people go there in these areas just because the houses look bad and nobody want to be near those houses. Now we can build this low income communities closer to the good areas as well, just because the houses right now, they look so amazing and so nice, but they still can be built pretty affordably.
Yes, and that's the key for the building industry and also the municipalities that fight these things, that as soon as you said half the cost for that part of the building, it just struck me that this is an excellent marriage for what you're doing all around. The third area question has to do with your business model. I'm wondering, do you intend to be in the manufacture of these robots and support equipment, or do you intend to license or lease the equipment, license the technology? How do you think about that part as you grow and scale up?
Yeah, so we believe that we should pursue the rental model, or let's say even like a printing as a service, because like this even industry of 3D printed houses never existed before. So right now we're like, how we actually should approach this to scale company fast. And now we're thinking like, what if we start doing all of the things at once and see which one is actually works better? Currently, we're selling the equipment. We also going to start renting this out. And then we also doing the printing as a service. All of the houses we printed so far, we were providing services to 3D print the walls. So we already kind of like, everything, at least that area. So we, as of today, we want to achieve 10,000 printers operating in the field. This is how we can build 1 million homes a year. So and now it's like what we should do, what the approach should be to achieve that goal. And I think we are just exploring this right now. But we know for sure that we don't want to be the construction company because it's so hard to build this business and scale. D.R. Horton, the largest home builder in the United States, they spent 45 years to build 1 million homes. We don't have so much time. So we need to figure out the different business model, how we actually can empower these home builders and they can start scaling our technology because they're already operating at scale.
Yes, and just one last observation, that there's also a cottage industry around what you're doing to provide the specialized maintenance and repair of that equipment.
Yep.
Completely separate business line that you need to be a part of somehow.
Yeah, exactly. And one of the mentor and investor from Unreasonable, he is actually helping us right now with the figuring out the rental business model. He built a very successful business in the renting the specialized industrial machinery. And yeah, he's saying there are a lot of profit centers, even your labor, maintenance, repairing, education. It's not just the equipment that you sell and rent out. It's the entire ecosystem that can create a lot of revenue streams for you. And it's also important to have to scale it sooner, the technology and adaptation.
Yes, thanks so much. And again, congratulations. Good
Thank
for
you so much.
Thanks, Victor. Adolfo, and then we'll go to Craig.
Thanks. Thanks, Anna. Incredible story. Thanks for sharing your story with us. So I had a number of questions. Victor already asked a couple of them, but let me expand on that. So how does that business model that Victor was talking about will expand to the Mars and Moon approach? What is your role there? Release the patent, provide the technology, license the technology. What is going to be your approach there?
Yeah, we don't have a lot of construction companies on Moon and Mars, right? So we need to figure out the different approach, how we get there. I think that when you're doing something in space and other planets, it's really the huge joint forces between incredible organizations and government support as well, even NASA. So it's definitely going to be a way different business model. Maybe we go into, provide the services for the government agencies or companies who already going to build something there, because I do believe that space does not belong to governments or government agencies. I believe that we're going to have a lot of private companies over out there, some of them going to mine asteroids and sell this resources to other companies who, for example, building something on Moon and Mars, or they provide the energy somehow for the companies or whoever is on Moon and Mars. It's going to be the full economy there. And for us, it's how we can be integrated in that new economy. Should we provide the printing services there? If that's the best way to do this, yeah, we will figure this out. Or maybe we will need to collaborate and cooperate with somebody who already is there, right? So it's a great question, but I think as long as we're able to provide this technology solution for that particular new market and in industry and infrastructure, this is another kind of a riddle to figure this out. It's also very exciting. Yeah.
Okay, so my main question, thanks for clarifying that. My main question is about the team, your team. Can you tell us about how the team has been growing up, what kind of team you have now, and the role of mentors, and since you are part of the Unreasonable ecosystem, how did that change the game for what you guys can do?
Oh, yeah, thank you for asking this. Our team has been so far historically very small and very lean. Because we're really happy that Nick, the co-founder and inventor and CTO, and my husband, he's a really talented, and he works equal to 15 people, I think. It's not something that we really want to continue. It's not so sustainable, but we were able to did significant progress just with the small team. It was like on average like 6-7 people, all of the engineers. And we believed that before we go and start selling the product, we need to create the product that customers and market cannot ignore. We can't really just, start raising a lot of money and then figure out what we're going to build. So now we're in a very exciting position that the technology is so well developed and tested and somehow de-risked. Now for us, it's just how we can go and scale it. And actually recently we had a very exciting change in our team. We landed or got on board a very seasoned executive and very nice, awesome person. I believe he's also Unreasonable. He is right now our CEO, and I transitioned to operational role. And I'm really excited about that. I was trying to make this for like a year, I think, but now we're really excited about that. So we're growing right now. And we really need to bring more talented people really to build organization and scale the business. And of course, like reinforcing the product development and technology. But I would say we did hard thing to build the product, but building an organization, I think it's even harder. Yeah.
Right. Well, fantastic. Thank you, Anna, and wish you the best. See you in March.
Thank you.
Thanks, Adolfo. Craig, and then we'll go to Matthias.
Yeah, thanks, Todd. Anna, congratulations. It's a fascinating story. Though I had two parts of my question. First part is actually related to your expansion. So it's the capital raising. I think you mentioned in the beginning you'd raised about $4 million from crowdsourcing funds.
Yep.
So is that the total you raise to date? And kind of with your expansion plans, they seem really aggressive, which is awesome. It sounds like the tech's almost right there. What is your plan for raising capital? Are you actively doing that right now? What are you looking at? How much are you looking at raising to go to that next phase?
Yeah, and so far we raised over $7 or $8 million. So it's like half of this from crowdfunding and half of this from the angel investors at One Ventures. They've been a great supporters and constantly supporting us financially, keep investing in us over this 3 years. And so right now, also with the Unreasonable support and mentors and investors, we are doing kind of like a small internal round, because those investors and mentors from Unreasonable, they bring in so much value to us. So we are raising open kind of like a small round now, but the plan is to kick off our priced equity round in the Q1 next year, maybe April. And that is just really we're thinking several dozens million dollars, because it's really needs to be a significant injection of the funding, because we just really want to grow and scale the technology. Yeah.
Thanks. Matthias, you're up, and then Roland.
Yes, thank you so much, Todd. I appreciate that. Hi, Anna. Before we're all taking off to Mars and the moon, I just want to take it back for a moment, and I just want to ask you, what is the biggest lesson you learned because you said you had to, or your mom forced you to finish your diploma in school while being an entrepreneur, and what are some of the pitfalls and lesson learned, and taking it back to what Todd says, well, what are some of the mistakes you made while being an entrepreneur and being in school?
Yeah, great question. Thank you. I think that don't really project how the world works based on your past experience, because your past experience may be not that relevant, because maybe you were not in the right place or with the right people. I think that before Unreasonable, I thought that people are so weird. And I thought that everyone like this in this world. But once I met people in Unreasonable and all of the other fellows, I was like, actually people, the world is not screwed. And my experience was just not really based on the right things. So I just really sometimes need to unlearn what I learned so far. So don't really, sometimes question what you think is right based just on your experience. I think we do need to unlearn sometimes a lot of things. And I think that another lesson is that you really need to work on your wellness, and I would say like your mental health, because as a founder, it's like you can work really hard for a long period of time, but I think really be a self-conscious and understanding what's happened to you, because like sometimes it's just so much stress, and see the life in a perspective that you actually have family, you have friends, you have health. Not a lot of people have the same, and you still have time and efforts to keep doing great stuff. And no matter how hard it looks like, nobody forced you to start a startup. Just remind it to yourself and just don't be afraid. And like one of the Unreasonable Fellows said, like if it breaks, it breaks, right? And I think sometimes we are the founders, we are so afraid of losing this, but most like 99% of the times it's not the end of the world. We're just thinking that it's the end of the world. And once you just think about this in a more relaxed way and a little different perspective, you actually can achieve even more, and you have more inspiration, and you're really getting into the flow state. So yeah, be less stressful, I would say. Find the way, find the tools that works for you.
Thank you, Anna.
Yeah, thanks.
Thanks, Matthias. Roland, and then Andrea.
Hey, Anna, it's good to hear like the dream you actually conveyed is very impactful, and it's good to hear those kind of pitches instead of just hearing a lot of like the many ones. I'm a data scientist, background in AI and machine learning. I'm gonna ask something not related to that though. Just one question I would like to ask you is does your current solution able to print on top of the existing structure?
What do you mean existing structures? It's like at the second floor or
second floor or extension?
Oh yeah,
let's say just if
yeah, we can do this. So for example, building in Dubai, it was each floor was 15 feet tall, but printer can print 10 feet tall when it's stationary. So we just, fabricated metal frame, like a metal pedestal that you can do in any garage. And we put the frame on that extension, and we kept printing. And
okay.
So yeah, it's very flexible and very agile tool that we have, just because of the sizes and how maneuvering it is. So yeah, it is possible, yeah.
Oh yeah, the reason I mentioned that is just curious, like the solution, is it backward compatible with all the existing construction industries, right? That's what I was curious about.
Oh yeah.
Yeah. And the other question I have is like, because I noticed it printed on the level of the floor, is it be able to print on uneven as well?
Yeah, but it should not be really that crazy,
Okay, just curious.
Yeah. As long as it's like some unevenness, you can do this. If it's like a real like a hill or really uneven structure, it's kind of like a challenging, because you still need to secure the printer on it. And why we print on the concrete slab is because we want to integrate our technology into the existing processes. And this is how it works today with the construction of single-family houses. You build the concrete slab first, you build it traditionally, and there is no reason to 3D print it. It's just the same as like a 3D printing, it's more like a pencil, and the concrete slab is just regular concrete pouring, it's more like a brush. So if you use printer to build your concrete slab, it's like you use pencil to paint the wall. You would rather just use the brush. So this is why we're like, okay, whatever is already existing in this process, a concrete slab, we do not change that process. Once it's done, we come and build the walls with just in a different way. We don't use labor to do this. We use the robot. Yeah.
And the one last one, do you what do you see for the AI and the machine learning fits into your company?
Yeah, it's we do want to, and we do have a roadmap to include machine learning and AI. And it's basically the reason for that is how to control and manage the printing process fully autonomously. So for example, even right now, we do have cameras that can see how the printing goes. And sometimes, for example, something happens with the material and it's stopped in extruding correctly. The way how we notice this, it's our operator, he's looking at the screen, right? But imagine that it can be detected by AI, and AI, or like the algorithm, can automatically tweak the system, like a more water, less material, and that can be fixed. So it can happen so smoothly. And the ultimate idea is that like how to print fast, great quality, without any downtime, and with less supervision as possible.
Gotcha. Thank you very much. That's all my questions.
Thanks,
Thank you.
Roland. Before I get to Andrea, York put a couple questions in the Zoom chat that I missed. He wanted to know about the pricing for like a residential unit, 2,500 square feet, and the sales to date, cost of production, and your profit margins. If you could talk about that, that'd be great.
Yep.
Thank you for that.
So, oops. I interrupted somebody now. Okay. So as I was telling, like we have like three approaches for our business model. Is just direct sales of the equipment to construction companies. Then we rent out this equipment to construction companies, and then we just provide the printing as a service. Current one that we are actively working on, like pursuing right now, and we have a great demand for this. It's the just purchasing the printers. We sell it as of right now for $650,000, and now we actually have plans to increase the price in January, and we hopefully going to get some money wired in the coming days for the sale that we just closed recently. And for our event, our printing process that we're doing for Habitat, the printing of the house, it's going to be like 50 people coming in over 2 weeks, and they're all construction companies. They want to see the machine in operation and get it acquired and start using for the processes. So we expanding right now as we speak. We expect to close more sales, direct sales, by end of December, and it's continue in January. Our goal for next year is to produce and sell 30 machines. And with the first year, as we're ramping up the production, our margin is not going to be that big, because like it's still, the manufacturing process as we learn and create. But on the second and third year, once we get in the more mass production, we plan to start producing 100 printers and then 200 printers a year. Our like a profit margin on the manufacturing of units is going to be like a significantly improved. Once we just complete the ramping up, it's going to be pretty good unit economics. And happy to share it in the private conversations. I just don't want to get it released on YouTube.
Yeah, and just to thank you, Todd. Sorry to cut in, and Anna, thank you. Fantastic presentation. Just wanted to know more about the margins and also about the sales to date. I'm thinking like an investor right now, and I just want to get an idea on that.
Yeah. So kind of like bringing you more context, is that previous years we have been working on the product and the technology. We didn't really sell the printers. We were doing this construction projects when we 3D printed the walls, with the ultimate idea how to create the first commercial version of the equipment and start selling it. So a couple of months ago, we finally achieved that, and we started sales. And the first sale we are about already closed. We're getting money today, tomorrow, basically, and we expect to close 3, 4, 5 sales in December. So we did have some revenue before, but it was more on the printing as a service. And now we actually just in the pivotal moment because customers are just basically knocking our doors and like, finally we can get your printer because they were asking us for years and we're like, we're not really ready. We don't want to give you the product that's not ready yet. And then with the new innovative technology, we're not going to have a second chance for the first impression, you know. So yeah, we actively getting the revenue as we speak. And I think also about the margin question on the material, our margin is more than 50% because our business model is also not just to sell the printers, but also supply the 3D print material and basically become more like a HP business model. And if we could, we would just deploy the printers for free with the idea that construction companies could just utilize printers very actively, because that means that we're going to sell a lot of tons of concrete to them, special blend basically. So we have a pretty good margin on the materials. And as we scale our manufacturing of printers, the margin of the printer going to be also like more than 50% at the year third when we at scale manufacturing them, more than 50%.
Thank you, Anna.
Yep.
Thanks, Jorg. Andrea, then Divya.
Thank you. Thank you, Anna. It's so incredible to get to hear your story and the connection between you and Kelly. He's absolutely incredible. So I have like two questions in one for you. At what point in your life did you know that you wanted to be an entrepreneur? And then what are some of the biggest challenges that you had at the early stages of the company when you were first starting it?
I think when I was really like a little child, I did want to be a teacher. And funny enough, me and my friend, we started a private school because she was very good at math. I was very good at physics. And we just opened really private, small school when we were preparing kids for the exams at school, or we were just tutors basically. So I think I all the time was like a little bit, you know, I just want to do things, right? I wanted to be teacher, but then I all the time, whenever I started to do, all the time it would end up being an entrepreneur. Even like when we started selling our stuff from home when we were kids with my sister, it was also like, yeah, we just need to do something. So I think it just kind of like in my core that I wanted to be entrepreneur, but I didn't know what exactly I'm going to do. And it's like, oh, I like this stuff. And every single hobby that you have, you automatically think how to turn it in some like a hustle, like, oh, I can do this, and I can grow. So I think it just really is sometimes in your blood, at least in my case scenario. And the challenges in the beginning, I think I never worked for anyone. I never had a boss because I started all of these things when I was just at the university. And I think that when you're a boss for yourself, you really need to have a lot of discipline. And you also don't know how to really manage other people because you manage all the time yourself. And I think at some point I was really bad at delegating. And I'm still like learning on this, honestly, because it was such a tough journey. We all the time was so short and limited in the resources. I still keep, you know, I needed to do accounting, I needed to do social posting, I needed to go and mix the concrete, and still doing this, unfortunately. So this is why I'm really hands-on with the technology. And I think, yeah, I wish I would have been better in delegating. So it's really important, yeah. But at the same time, when you're early, you need to really learn every single aspect of your business. This is how then later you are able to hire right people because you know how it should be done. And it's really hard to, you know, trick you because some people are so good at selling themselves and you can believe them. And in reality, they have zero skills. I'm really happy that I've been on all of the construction projects. I know everything about this concrete, honestly. And now if somebody telling me like, oh, you need to do this, this, and this, I was like, no, I know. I really mixed a lot of concrete. So I think it's important in the beginning. Yeah, but now, and historically delegating, yeah, I think that was a challenge for me.
Thank you, Anna.
Thanks, Andrea. Divya, and then we'll end it with Susan.
Anna, it's so good to see you. I mean, as always, totally in awe with everything. You've done so much, and I love how you just make everything just sound like it's a matter of fact. right? Like you're just so grounded, and I just love you for everything that you've done, and just so humble about everything. So my question is just going to be something more broad, and a lot of the HBAP folks know, probably have, come across this at some point. What do you think is your superpower?
Being able to survive and adapt, and I think also to learn things fast. Yeah, I think this is actually like the superpower. I really good when people give me the feedback, and I also very curious. So this is something that I think also helped with the building the really great relationships with D.R. Horton, because I all the time use them as a resource. Because some of the companies, or like startups, they come into the customers and say like, whenever you've been doing it's wrong, we know how to fix it. And they're like, yeah, you just started it, it's wrong. But we like, yeah, can you tell us how you actually works, how that works? And we need to figure out if our solution is going to make sense for you. So I think I just really good at like asking right questions and be just really curious, and then quickly apply it practically and learn really fast on that. Yeah.
Awesome. We got to catch up soon.
I wanted to call you before this call.
No, I knew you were going to be here, so I thought we'll do a surprise, but we will catch up soon enough. I'll let you catch a break, and then we'll definitely catch up soon.
Yeah, thanks.
Good to see you.
Thanks, Divya. Susan.
So this has just been so incredible, Anna, and I am in the construction industry as well. So this has been really fun to think about, and millions of questions, because I mean, this has been my life for the last 30 years. So would love to catch up offline with you. And also just talk about some additional opportunities, especially around data centers and things like that. I'm actually working with 3 engineering companies right now on how to make data centers cheaper. So
nice.
Yeah. Anyway, awesome, incredible, wonderful. So our question that we always ask our speakers is, what can we do to help you?
Oh, you already helped. I had so much, really enjoyed being here, and it actually reminds me Unreasonable as well, because it's really nice to be around people like this, and just giving me this opportunity to share my story. That sometimes I'm just thinking, whatever happens, you need to keep moving. But I'm really happy that it may be helpful for some of you. And I want to be the resource for you as well. So feel free to reach out to me. And if I can help, I will do this. And I think, and more like on the practical business, side, we right now really exploring the best ways how to scale faster, and really like how to grow the company, and all of the business connections with their potential customers, more construction companies. That's awesome what you mentioned, Susan. And also we need to get more really talented A team put together. So we need, VP of manufacturing, and also VP of business development, sales. So if you know brilliant people who want to be part of the team that changing the world, and being the first, the team that going to build DNA of the company. If you know people like that, I would be really happy to speak with them. Yeah.
Awesome. Definitely.
Susan, thank you. Anna, this is a pleasure. This was really an honor. I want one of your houses desperately. So like, and one of the things you said that you were targeting this as like affordable housing, and in my mind, and when I look at the competitive landscape, which is significant, but like to me, these are not low cost. This is like premium housing. This is like, I want this, because the traditional ways of making homes are not as exciting to me, and that's what I want. So to me, this is like luxury, not about low cost. The efficiencies that you are able to build with this, I think, is fantastic. So
thank you.
As soon as you can get me a house, please, I would love one. But on that note, I just want to thank you again and just invite everyone to stick around for some overtime. We're going to end the recording here. And just as a little reminder that next week, Clasanda Armstrong Grandison, the design director at Alaska Airlines, will be joining us. And please do stick around for some overtime. Thank you all for coming.